Hey everyone, welcome to my YouTube channel called Duodecimal Division. My name is Eric Larson and this is a YouTube channel all about base 12 mathematics and specifically base 12 geometry. So just a little bit of information about myself. About 5 years ago I was fortunate enough to go on a trip to Egypt, and while I was there I came across the idea that perhaps base 12 mathematics was better than base 10, that base 10 was flawed, and that therefore the base 12 version of pi was somehow better than the base 10 version, that the people who built the pyramids were using base 12 mathematics. So this idea intrigued me, and so when I came back I started exploring it. And rather naively, I didn't really know much about mathematics at that time. I started taping pieces of graph paper together and drawing circles, and eventually I made some discoveries. And the really big discovery that I made is this geometric pattern right here. It's a dodecagon, a 12-sided shape. Each of the sides is the same length, and you can see here it's a growing pattern. So the first ring has the length of 5 root 2, then the second ring is 2 times 5 root 2, then 3 times, and so on. And the reason that we've missed it, or that it hasn't been noticed in base 10, is because when you compare base 10 and base 12 as far as the geometry, the size of the units, when you divide the 1 into 12ths instead of tenths on the Cartesian plane, those units are smaller. So this pattern doesn't land on the 1 the same way that it does in base 12 if you're coming at it from base 10. You can see here's the example of base 12 and base 10. Can't remember which one's which, but basically you can see how it looks bigger. It is bigger. It's a larger shape in base 10 than it is in base 12, and doesn't have that same relationship to the 1. So that's a critical difference. So in base 12, this shape lands on the 1 in a way that it doesn't in base 10. I go over that in some videos on my channel, and basically what I do on my channel is explain to you how to take this pattern and use it to create the diagram for 360 degrees. So what this geometric pattern does is it gives us access to the geometry of the circle in a way that we've never seen before in base 10. So in base 12 we're able to create the diagram for 360 degrees. So that's what this looks like here. This is something that I built in my basement using this geometry. It's a pattern that after 30 rings we're able to divide the circle up into 360 degrees. It sort of builds on itself. We start with this pattern, I think it's called the seed of life, to generate that first division of the circle into 24 equal sections. And then we sort of work with that pattern and the dodecagon, and we continue building rings. You can see here what it looks like, and eventually we get to 360 degrees. So we know the perimeter of the dodecagon right away, and we know the diameter of the circle, the radius of the circles that we're using right away. So it's actually built into the process of creating this diagram that we're dividing the diameter into what starts as the perimeter of the dodecagon, but eventually ends up as being the circumference of a circle. We're delineating specific points on the circumference of the circle. So what I'm doing now, I'm continuing my process of exploring this pattern, and I'm making larger circles and seeing what happens as we go farther. What does it look like as we explore the circumference of the circle using this geometry and start, continuing making, plotting more and more points on the circumference. At the end of this diagram, we just have basically each 1 degree section is divided into quarters. So we actually divide the circle into, I guess it's 1,440 equal sections. So to keep going with that pattern, to really go into the millions and billions and trillions, that's the series of videos that I'm working on now. The one that explains how this pattern works, or how to construct the diagram for 360 degrees, there's a playlist on my channel called Explaining Base 12 Pi. So you can find that here and take a look at that. I just made a series of 2 and 3 minute videos going through the steps, explaining all the geometry, the lengths in base 12 and everything. So that's one aspect you can find on my channel. Another is a discovery that I also made, that whoever it was that we inherited 360 degrees from, because I believe that we inherited this pattern from people that were using base 12 math. This isn't something that you can draw in base 10. There is no diagram for generating the points on the circle in base 10 as there is in base 12. I believe this is the diagram. This is the way you have to do it. It's something I've discovered. It's not an invention. It's a discovery. And they also are responsible for the design of our numerals, the Western Arabic numerals. I discovered that all of the numerals actually fit a pattern in base 12. This is actually what that pattern looks like. You can see it's a series of concentric circles. Each of those circles you know, you see they're all larger. They have the radius of the square root of 2, square root of 3, square root of 4, square root of 5, and each numeral relates to its corresponding circle. And there's geometry in there that's sort of wrapped up in the design of each numeral that's very relevant to the numeral. And each numeral contains the value of the number that it represents, actual lengths of lines. I'll show you actually for the numeral 2. This is a good one. If you look at, here we are, it's the second circle in the series. So that curved top of the numeral is the circle with the radius of the square root of 2. Those 4 points that define the numeral, that shape of it, are the 4 points that also define the position of that circle. And if you look along the bottom of that symbol, that length of line is the length of 2. So each numeral has all those qualities. So that's something else you can find on my channel. There's a series of videos called Secrets of the Numerals, where I explain and go over all the lattice points and how each numeral is, again, contains the value of the number that it represents, relates to its particular circle in the series, and also contains some other mathematical information. So it's a lot of new discoveries that I made. I think that's how the numerals came to be. You know, there is a story about them. Well, they're called Western Arabic numerals because they were discovered in North Africa by Fibonacci. At that time in Europe, everybody was using Roman numerals. So that's why they're called Western Arabic, because that's where he found them. But it doesn't really explain who made them or the logic that they use. So that's something to think about. These aren't official narratives at all. These are discoveries that I made, and I'm offering them to everybody as food for thought. So the value of pi is a base 12 version. When you divide the diameter into the perimeter of this dodecagon, you do get a number. It has different qualities than the base 12 or the base 10 value of pi. There's a repeating pattern eventually. A lot of new stuff. So I go into all of that. It's food for thought. I welcome you to my channel. I'm going to keep making videos and exploring